Okay, so we're going to go over higher order derivatives, which will help us solve questions involving velocity and acceleration. When we talk about higher order derivatives, what we'll be doing is finding the second derivative of a function. Okay, so we have our function here, and we're going to relate them to velocity and acceleration. So to derive this function in prime notation, we just have f prime x, and when deriving it, we bring our 3 down. We have 15x squared minus 4x. And I'm going to change this so that it reads 5x to the negative 1, so that when we derive it, it becomes negative 5x to the negative 2. So the end of this is negative 5x to the power of negative 2. This is our first derivative. And in terms of velocity and acceleration, our first derivative help us solve velocity questions. Okay? In other words, if this was showing the path of some object, this equation here, then when we derive it, this would give us the velocity of the object at specific points in time, assuming x represents time. Okay? The second order derivative is just taking the derivative of our derivative. So we take this function and we're going to derive it again. We denote it using f double prime. Okay? This is our second derivative. So we derive this function again, we end up with 30x minus 4. And here we'll get plus 10x to the power of negative 3. So this is our second derivative to this function. And this helps us solve questions involving acceleration. Okay? So again, if this equation on top was giving us the path of an object, our first derivative helps us solve for the velocity of the object at a specific point in time. And our second derivative helps us solve for acceleration at specific points in time in reference to x. Okay? So really, to get to a higher order derivative, all we're doing is deriving a function twice, and this is how we denote it. So let's get into an acceleration question. We have a particle that moves along a straight line, okay, with this equation of motion. So they've given us our original. I'm going to denote this as velocity. Okay? So velocity in reference to time is equal to our s prime t. Okay? So we have to find the derivative of this function to find our velocity. So I'll write that on the side here. Our velocity, which is equal to s prime t. And now what we'll have to do is we'll have to derive this function. So we bring our 3 down. This will become 1. So we have t squared minus 4t plus 3. So this is our velocity function, which is also equal to the derivative of the function with our straight line here. Okay? So let's say we wanted to find out when an object's velocity is 0, which means it's standing still. What we would need to do in this case is we need to set the velocity equal to 0. This will let us know instances when something is standing still. So if we set it equal to 0, we have t squared minus 4t plus 3. We'll factor this. When we go to factor this, we have 0 is equal to t minus 3 and t minus 1. Okay. We factor the equation above. We're going to set both equal to 0. T minus 3 equals 0. T minus 1 equals 0. And at the time of 3 seconds and 1 second, our object is standing still. So if we were to do this on a timeline, okay, and if you guys recall from the very beginning, our time was equal to and greater than 0, so our lowest time was the value of 0. At 1 second, this object has come to rest, and at 3 seconds, it has come to rest. So what we really want to find out is the directions it's going. Okay? So we'll try to find out the direction between 0 and 1 and the direction between 1 and 3. For all we know, it went in a positive direction, stopped, and went in a positive direction again. Or there's a possibility that it went in a positive direction to start and the opposite direction until 3 seconds and then maybe changed again. So there are 3 intervals, and anything greater than 3 we'll have to figure out. So we're going to be looking between time, sorry, not at 0, time between 0 and 1. We'll be looking for time between 1 and 3. And we'll be looking for time when it's greater than 3. Okay? So in order to figure this out, we're going to take our values, and we can take any value in between these, and plug them into our velocity question or their derivative here. And this will tell us if something is moving in a positive direction or a negative direction. Okay? So first one, we'll take a value of a half. We'll plug it into here. So we're looking at a velocity when time is a half second is equal to a half squared minus 4 times 1/2 plus 3. We get a fourth minus 2 plus 3, which will give us 1 1/4. So we have a positive value, and that's what's important here. A positive value means we're moving in a positive direction. So if this is our number line, we'll just assume that this is our positive direction if it's a straight line, right? They said the question was a straight line. So we're moving in our positive direction. So let's get rid of our hypotheticals here. So this thing moved in a positive direction up to 1 second and then stopped at 1 second. Then we're going to find out if it continued in a positive direction or went in a negative direction from numbers 1 to 3. So we'll take the value of 2. Our velocity at 2 seconds is equal to 2 squared minus 4 by 2 plus 3, which gives us 4 minus 8 plus 3. What do we get? -1. So what this means is this now moved in a negative direction. Okay? So if we were really to draw this object, let's say this is our line here. Let's say it started in the middle at 0 seconds. For 1 second, it moved in a positive direction, then stopped. And then from 1 second to 3 seconds, okay, it moved in a negative direction, then stopped. And then we're going to see if it changed directions again at 3 seconds. It could have continued in a negative direction. So we'll take any value above 3. We'll do this in blue. Yep, so let's take 4. Velocity at 4 is equal to 4 squared minus 4 by 4 plus 3. Is that right? I'm just going to double check the equation. Yeah. Okay. So this gives us 16 minus 16 plus 3. So this is a positive value again, which means at 3 seconds, it finally took off in a positive direction and went that way forever. Okay? So this helps us with velocity in terms of which directions things are going. 0 means it's standing still. A positive value gives us a positive direction and negative a negative direction. But let's talk about acceleration also. Okay? So we'll take this equation which we had from above and put all of them down. So our original equation was 3 cubed minus 2t plus 3t minus 2t plus 3t. Okay. Our derivative or velocity was equal to t squared. This was squared, wasn't it? I believe that was. Yeah. Minus 4t plus 3. And now what we're going to be looking for is the second derivative, or the derivative of velocity, which is equal to our acceleration in terms of time. Okay? So these are just denoting everything. Our original equation, we have to find the second derivative if we're looking for the acceleration. If I have the velocity equation, I only need to find the first derivative of velocity to be equal to acceleration. So we're going to derive this function again. When we derive this function again, we get 2t minus 4. So this is giving us our acceleration in terms of time. Okay. So remember, we had some key points. We know we started at 0, and the time of 1 second and 3 seconds were important to us. What we're going to do is we're going to plug in these values to see what's happening at those specific times. Okay? So we have our velocity, we have 0. Oh, did we plug in 0 above? No, we never did. So let's just focus on 1 and 3, and we'll see what they give us. We're going to plug in the value of 1 into our acceleration to see what's happening at that point in time. So in terms of acceleration, at 1 second, we have 2 I1 minus 4. So it gives us -2. Okay. So acceleration is a negative value, and at 0 in time we were standing still, okay? Which meant it was starting to head in a negative direction, okay? And it was accelerating in a negative direction. At 3 seconds, acceleration at 3, 2 by 3 minus 4, we have positive 2. Okay? And at that point, it was standing still, so it was starting to accelerate in a positive direction. Now, did they give us parameters here, meters per second or anything? No, they didn't. So let's say that this is moving in terms of meters and t is time. Okay? So t is time and our object is moving in meters per second, t being seconds. If we were to denote this stuff, our velocity, when it was positive, so at a half second, we were moving at 1 1/4, so 1.25 meters per second. At 2 seconds, we were moving at negative 1 meter per second. And at 4 seconds, it was moving at positive 3 meters per second. Okay? At the times of 1 and 3, this was moving at negative 2 meters per second. Per second. Okay? So we double up. In other words, this is meters per second per second. Is how we denote acceleration. And that same thing is used for our other one. We're going at 2 meters per second. So I'm just going to write it like this as a short form. So it's accelerating at 2 meters per second, and it was decelerating at 2 meters per second. Now what we also want to test out is our values that we put in of a half, 2, and 4. What we're going to do here is we're going to take in our half, our value of 2, and our value of 4. We use these times, okay? And we're going to plug them in to find out if it was an accelerating at this time or decelerating at this time, okay? And in order for these events to happen, if velocity and our acceleration are both positive, or sorry, both the same sign, I should say, not positive. Both the same sign, then we're accelerating, okay? If velocity and acceleration are not the same signs, then we're decelerating, okay? So, at these points, our velocity in time was positive. Here it was negative, and here it was positive. Okay? We're going to plug these values of our t into acceleration at those times to find out if it's positive, negative, and positive. So if it was always accelerating or if it was decelerating at those times. So our equation of 2t minus 4, 2t minus 4. So we plug in a half, we get 2 times 1/2, which gives us 1. Acceleration at a half. Squeeze that in. We get 1 minus 4, which gives us negative 3. So we are at negative 3. So at this time, it was slowing down this object at a half second. And we would have to test each of these seconds to find out what it's doing at each of them. Our second one is acceleration at 2 seconds. So we have 2 by 2. At this point, we have no acceleration. Okay, so it's at a constant. Rate of change of, and what was it at that point? Anyone remember? -1 meter a second. So it's moving at 1 meter a second at a constant rate. So if our acceleration is 0, it's not speeding up, nor is it slowing down. Okay, so here we had a value of 0. And finally at 4, a at 4 is equal to 2 by 4 minus 4 gives us positive a. So it's a positive. So this was accelerating at this point. Okay, so we had it slowing down, deceleration, no acceleration, and then we have acceleration. Okay? So that's how we relate our values to acceleration and velocity. Yeah.